question number 29, we have the angle theta in standard position, and it tells us the cosine theta is -1/2 and sine theta is -√3/2. So we're first going to look at the sine of this to determine the quadrant. So that's how we're going to help figure out the angle where theta lies. Okay, because theta is again measured always from standard position, and we need to know where theta lies. So if the cosine is negative, cosine is horizontal and it should go with the x, so we can see that the negative x should go this way. The sine always goes with the y, or vertical, and so if the sine is negative, that means that the vertical positioning is negative, so it's going to go down this way. So it has to be in this quadrant here. It has to be in quadrant 3. So that's the first thing. We need to establish the quadrant it's in. The ratios then tell us the reference triangle, where we can, the angle that we can find. Now, the ratio of 1/2 and √3/2, they are special angles. So we should relate that to a 30-60 triangle. So when we talk about 1/2 for cosine, we know that the horizontal is 1, the vertical is 2. That relates to 60 degrees. And same with the sine. The sine is going to be √3/2, the opposite over the vertical over the radius, and so we get 60 degrees there. So the 60-degree angle is going to be our reference angle, and it's going to be going vertically down √3 and horizontally across -1, and that's going to be, this reference angle is 60 degrees. So to work out the standard positioning of this angle, we then measure that angle all the way from 0. And so we're going to end up starting at 180 degrees over here. And then we can use that reference angle of 60 degrees. So we get theta, angle theta is equal to, we're going to start at 180 degrees, and then we're going to add in that reference angle of 60 degrees. And that gives us a position angle. The positioning is then going to be at 240 degrees. So the standard position of this is at 240 degrees.